So we're on site here out in Pakenham area on top of a manufacturing facility. Now in this situation there's two systems. They're quite small. We're talking about two 30 kVA inverters, both sun grows, but they're both separate systems. Each one has about 39 kilowatts of Jinko panels. This is a Cleanliness rail. Now the roof type is a trapezoidal type of roof, and you can see there's a flat section here. So this is a penetrative system. We are actually penetrating into the purlin, and you can see with this L foot here, and then there's a bit of EPDM just to separate the two different metals. So this is one of the L feet. We've used glue here, and this effectively separates dissimilar metals. Now in the situation of this particular roof and aluminium, the chemical reaction between the two will be negligible, but better to be safe than sorry to have this actual barrier between the roof, in this case the trapezoidal roof, and the actual L foot itself. So you can see very robust. Here you've got a little bit of you can see the aluminium's been cut away, so it's sort of slotted. Now you've got a hex head here, and if we turn it around slowly, this is the design that actually allows you to connect the rail, right? Notice it's a slot. Now, this is so you can actually lift them up and down to get the rail straight. The reality is, roofs should be all dead flat and straight, but they're not. And it's up to the poor solar installer to actually make sure that the rail is as flat and straight as possible. The thing about rail, it doesn't come in lengths of infinity, right? It comes in predetermined lengths, and these lengths tend to change year by year based on the popular panels that are out there in regards to their width, because there's a relationship between the length of the rail and the width of the panel. The ideal situation is that you configure your design in such a way that you don't make any cuts on the rail, but invariably there will be joins. And you can see here, this is a splice join here. So this is effectively creating a connection between these two pieces of rail, and also, as well as structurally, it has to maintain the earth as well. We're using two systems here. We're using the Cleanliness rail, standard Cleanliness rail with an L foot, penetrative system straight into the purlin, but we're interfacing that with a 100mm Sunlock cable tray. So this cable tray is quite cute, and I haven't seen it before because I haven't been on site for a while. I'm used to 150, 300, 450, 600, etc. But this is 100mm, and obviously it's accommodating the earth cabling and also the strings. Now, if you notice here, we've got a catenary wire that is allowing a connection between the earthing connection between the two rails. Now, when it comes to earthing, there is some hard and fast rules, especially after the newest AS 4777.1 2024. What we're talking about, if you are using string fusing on your arrays, you can use a minimum of 6mm earth. Now, when I say that is length dependent, because it comes down to the resistance not exceeding 0.5 of an ohm. Now, if there was no string fusing on this particular job, you would have to match the earth that is used in for the inverter. So say for instance, if you were putting, because I know this one, 110 kVA sun grow, and you're using say 95mm red, white and blue, you'd be using a 25mm earth. And if you're using no string fusing on that particular case study scenario, this earth would have to be 25mm. So really, it's probably a good idea to use string fusing. There are situations where our clients may stipulate no string fusing because they see it as a potential point of failure. We've done enough of these systems to know that that's not really the case, and you save considerably on the cable costs. So in this situation, we are going FTR. That's an acronym that stands for flat to the roof. Now with flat to the roof, when you've got X amount of roof real estate, you can actually put more panels. But there's a trade-off in regards to the average production, because obviously when when the panels are in a flatter configuration, you're going to produce a heck of a lot more during the summer months when the sun is directly overhead, as opposed to the winter months. Now, if we did go down the road of a pitched process for these panels, then you have to take into consideration the shading of one row compared to another row, and therefore your total available roof real estate is reduced. So there's a trade-off between maybe producing a more consistent average output with a pitch configuration, especially if you do an east-west configuration, as opposed to flat to the roof. But so from a roof structural engineering perspective, it's not just about the distance of the purlins, it's also the thickness of the purlins themselves. So any kind of commercial job, and ideally a domestic as well, you're going to go into not only the spacings of the purlins, but the actual material of the purlin, the configuration, and the actual thickness. Because remember, at the end of the day, that what's holding these roof sheets on is a system that is actually penetrating into the purlins, and we're going straight into the purlin. So we have to make sure that that purlin is of an appropriate thickness. There has been cases of purlins being less than a mil, 0.6 of a mil, and some purlins way over 1 mil. Obviously, the thicker the purlin, the more purchase you get with your hex head. Now, protuberances. What I'm talking about is HVAC. In some situations on some of the very large commercial solar systems, we design the system, the owner signs off, and maybe the actual installation starts in six months' time. And sometimes in that 6 months period, strange things can happen. In other words, HVAC. In this situation, we were aware of the HVAC and we designed the system around that because of the shading aspect. But in a lot of cases, we've come to site and unbeknownst to us, the owner has employed an air conditioning specialist or an HVAC specialist, and suddenly there's all these things all over the roof, and we've had to go and do a radical redesign of our string configurations. Ideally, make sure in your contract that you take that into consideration, because you do not want to be redesigning it after you spend all that time, unless it's a variation. So what we do, we get a specialist guardrail provider to come in here with a certified product, and in addition to that, we actually get a lovely bit of paper that is part of the handover and also goes straight to the customer to show that the actual handrail that we're using, the guardrail we're using, is fully certified, right? Now this is really important from an OH&S perspective and also from a legal perspective as well. Really important too is that someone else has signed that bit of paper. Remember, Greenwood are not experts in handrail, and neither are you. So make sure that you're using an accredited handrail provider or guardrail provider, and that they, as a bare minimum, provide a document that you can reference and also that you can pass on to your client. Really important. Okay, so I'm holding one of the most important documents you have on a commercial solar system, and that's the recipe book. So what I mean by that? Well, effectively, we're talking about the certification, for example, with the guardrail, other important documents, and very importantly, the actual drawings of the string configurations of the panels. So effectively, this is the panel configuration here. You're talking about Jinko solar panels. They're 510 watts each, 78 panels, total of 39.78 kilowatt peak, and that's for roof one. Obviously, we're using a sun grow here, a 30 kilowatt sun grow. Well, actually 30 kVA. Let's be precise about this. So this is a site setup showing things like bollards and bunting, skylight netting, the guardrail, small electric EWP to access underside of roof for the DC drop, storage area, bin, emergency assembly area, very important, the EWP for the roof access, and another storage area. So it just gives you a visual representation of where things are. Again, it's the book that should be on site. And the beautiful thing is that a lot of the information in this in this particular A3 folder can be replicated in A4 and be put in as part of the handover / customers / owner's manual. Really important, so you don't have to double up. But it's really important that the guys on site have got something like this. Look, invariably, on the bigger jobs, there may be changes in the rail configuration due to unforeseen circumstances like additional HVAC suddenly appearing, or the accuracy of drawing to a near maps image. So on the really big jobs, you're drawing, the engineers are drawing out the in AutoCAD or something similar. And by the way, you can do it in Excel as well, and we've got a training for that at Greenwood Academy. Check it out. But the reality is sometimes when you come on site, those slight differences from reality and from the actual near maps image may require the site supervisor or leading hand to do some slight design changes. So that's something you have to take into consideration. Look at the catenary wire. Now you can see this catenary wire, effectively it's structural. It's designed to actually keep the cabling, in this case earth, but a lot of catenary wires will carry both the earth and the DC cable, and they'll be clipped here, here and here using a stainless steel cable tie. Now this particular catenary wire is quite heavy duty, stainless steel, but it's also got a plastic covering. Obviously it's a little bit easier to handle. You're not going to get any issues with any braids coming and scratching, creating some puncture wounds, or even any issues with the cable rubbing, the actual DC or earth cable rubbing against the actual catenary. So, because it's very, very smooth, right? Now, I'll draw your attention to all the earthing as well. Notice the earthing here has been sprayed. They've used a silver Galmet spray, and that's just to protect the earth from corrosion, because remember this is copper. Now there is a Galmet out on the market that is a green Galmet that some people use to distinguish between a standard Gal spray over say with a cable tray and the actual earthing. But I think for the ease of the installer, having a standard colour is fine. There's no requirement for this to be a different colour. So this has been sprayed here, and it's been sprayed here. Now you can see also too, a little bit of conduit has been used to accommodate the earth cable here. Now remember this is not sealed, it's purely mechanical protection travelling from this earthing point into the actual 100mm cable tray here. So you can see, so it doesn't have to be sealed in any way, shape or form. Whereas in some situations, obviously, you do have to actually seal the conduit, but not here. It's purely mechanical protection. Notice the site is really clean. By keeping the site clean, not only do you know where things are, there's less tripping hazard, and also it inspires confidence for your client. If he sees you're taking care in the work area to keep things clean, by logic, he will also think that you're doing a very neat job up on the roof, which of course, that's what you're doing. Have you noticed something really about this particular area? It's a demarcated zone that we've, within the agreement of the owner, it said this is our spot. Whilst we do the actual installation, this is our area. It's really important that you get the owner to sign off on that, because the last thing you want is to come to site and find this area covered with their stuff. So make sure you get the owner to say, yes, this is your area, this is your work area, no one's coming in this area, and we demarcated with some flags. Things are quite neat. We've got our DC cable here. We've got some components here. We've got some, for instance, we've got some mid clamps here. We've got some L feet. We've got some shackles for the safety netting. We've got some panels over here. Now, I'll draw your attention to these two big storage boxes. I'll call them big eskies. This is a really good idea that Joel came up with. We take these onto the roof. Now, at the end of the day, instead of taking all our tools down, we can leave our drills up on the roof. Of course, we take the batteries down and recharge them, but we can leave the skins up on the roof or anything of value up on the roof. This is totally waterproof. We've got a handle situation. We can lock that down on the roof in case of cyclonic winds. Luckily, we don't get those in Victoria, but it's always good to be very careful with this kind of thing. So we got these two boxes. You can keep whatever you like in there. They lock off. It's a really good idea. I'm very impressed with this one. We hope you enjoyed this look at what goes on on a small commercial solar project. Don't forget to like, comment, subscribe, and of course subscribe to YouTube and Greenwood Academy, where you'll see a lot more of this content. And if you've got any suggestions, let us know. Thanks very much. See you next time.